Good afternoon to all of you. Myself, Professor EMI-Errors from SNT College of Engineering and Research Center, Development. Now, in a previous video, we have studied the topic that is torque equation of energy single phase induction type energy meter. In that, we have studied that the torque equation of driving torque equation of single phase induction type energy meter. In that, the driving torque it is directly proportional to the power consumed by the load. Now, in today's video or today's lecture, we are discussing about the errors which is present in a single phase induction type energy meter and how to reduce or how to compensate these errors. There are 7 types of error which is occur in a single phase induction type energy meter. First one is phase error, second one is friction error, third one is speed error, fourth one is creeping error, fifth one is temperature error, frequency error and overload error. Now we will discuss the one by one. That is first phase error. We know that the in previous video we already studied that the construction, working and torque equation of uh, energy meter. In that we already studied that the phase angle difference between the flux of shunt current coil and flux of pressure coil, current coil flux and pressure coil flux, the angle between that there is a 90 degree, exactly 90 degree. But in practical cases, the pressure coil circuit has some resistance, has some resistance. Its circuit is not purely inductive. Means every coil having some internal resistance, and due to that the coil which is not purely inductive, then due to that the current taken by the current coil does not lag the applied voltage across the pressure by exactly 90 degree. By exactly 90 degree means due to the coil resistance, the phase angle should be less than 90 degree. Should be less than 90 degree. Due to this, the error is introduced in the energy meter and it is known as phase angle error. Means according to the resistance of the pressure coil, then due to this the error will be occur in the reading, and this is called as phase angle error. Phase error. Due to this error, the meter will not read accurately at all the power factors. Means as the power factor changes, the meter reading should also change. To reduce this error, some adjustments are done in the construction of the meter. To increase the inductance of the pressure coil, it is placed on the central limb of the shunt magnet core. Means for reducing the phase angle error or to increase the inductance of the pressure coil, means for that purpose we wound or we place the pressure coil on central limb of the shunt magnet core. To increase the inductance further, a copper shading band is placed on the central limb of the core of the shunt magnet. By moving the copper shading band along the limb, the inductance of the pressure coil can be increased. The inductance is adjusted to such a value that the circuit becomes purely inductive. Means for reducing the phase angle error, there are two adjustments. First one is to wound the pressure coil on the central limb of the shunt magnet, and second one is copper shading band, which will be adjusted. It will be adjusted, moving moving to a moving upward and downward direction for increasing the inductance value. For increasing the inductance value, and the shading band, the copper shading, which will be adjusted in such a way that the the pressure coil circuit having purely inductive. It will be made as a purely inductive circuit. This is your phase angle error. This will be occur due to the resistance of the pressure coil, and this will be minimized by using two methods. First one is wound the pressure coil on the central limb of the shunt magnet and adjust the copper shading band. Second one is a friction error. Second one is a friction error. When the aluminum disc should be rotated, when the aluminum disc rotates, there is friction at the bearing, spindle bearing, and the registering mechanism. Due to this friction, frictional torque is developed, which is opposite to the driving torque, and due to this, the error introduced in the meter reading known as a friction error. These errors are serious, particularly at light load. At light load means when the aluminum disc rotates, at that time this will be the friction will be occur during the bearings of the disc and disc, and this due to this friction between the disc and your brushes, then this will be produces the frictional torque, and this is which this will be opposite to the driving torque. Means this will be reduces the driving torque. This will be reduces the driving torque, and due to this, the speed of the disc should be reduced. This is called as frictional error. It is necessary to arrange for a small torque whose value is independent of the load on the meter and whose direction is same as that of the driving torque. The magnitude of this additional torque should be equal to the frictional torque. Means at no load condition, we should be adjust or we should be add the one small torque which is in same direction of the driving torque, and this will be used when the frictional torque produces. This will be neutralized. This will be neutralized or compensate this friction torque with these independent additional driving torque. This is usually obtained by a small shading loop placed between the central limbs. Small shading loop between the central limb of the shunt magnet and the aluminum disc to slightly on the one side of the central limb of the shunt magnet. Means for that purpose, for addition of these poles, we use the shading loop, which is in between central limb of the shunt magnet and aluminum disc. This shading loop should be used. Yes. There is an interaction between the portion of the flux which are shaded and unshaded. Due to these loop currents get induced in the aluminum disc, and due to this current a small driving torque is created. Means when the flux which will be cut by the shading loop, this will be produces an torque. It will produces an torque. This is in same direction of the driving torque, and this is helpful to increase the driving torque. The value of this torque is adjusted equal to the frictional torque by the lateral movement of the shading loop. By the lateral movement of the shading loop. Means the adjusted torque or the frictional torque, this will be adjusted by moving this shading loop, upward or downward direction. Upward or downward direction. This is your frictional error. For reducing of the frictional error, only one adjustment is shading loop and vary the position of the shading loop. Next one is speed error. Third one is speed error. Sometimes the speed of the disk is more or less than rated speed. Hence the meter gives error in the recorded value. This error is known as the speed error. Means when the speed of the disk should be increases or decreases, uh, uh, increase or uh, decrease from the rated speed, then it is called as speed error. And this will be reduced with the help of brake magnet. With the help of brake magnet. If the speed of the disk increases, then we will move the braking magnet towards the disk. And if the speed is increases, uh, decreases, then the braking magnet should be away from the aluminum disc. If the speed of the disc is less than the required value, then the brake magnet is moved towards the spindle, and this reduces the braking torque value, increasing the speed. If the speed of the disc is greater than the rated speed, brake magnet is moved away from the spindle. This increases the braking torque value, reducing the speed. Means by changing the position of braking magnet or brake magnet, we can adjust the speed of the disc. Means if the speed is less, then braking magnet which will be moved towards the spindle, means move towards the spindle, and as the speed is increased greater than the rated speed, then the braking magnet will be moved away from the spindle. Next one is creeping error. Fourth one is creeping error. Due to excessive voltage across the pressure coil and incorrect frictional compensation, the disk of the energy meter makes slow but continuous rotation when only the pressure coil is excited, but there is no current flowing through the load, that is through current coil. This is known as clipping of energy meter. This is a serious error. That is, if the load is not connected, means the current flowing to the current coil is zero, then at that time, only when the supply is given, that is, only voltage is given to the pressure coil, and due to that, the meter, the rotation of this, uh, it is available, or the disc should be rotated, then it is called as creeping error. It is called as creeping error. Creeping error, and this will be due to the incorrect frictional compensation also. This error should be also due to the incorrect frictional compensation. Due to this meter, the meter records some energy consumption when load is off condition. To avoid creeping, two holes are cut in the aluminum disc in opposite direction about the spindle. Due to this, the rotation of aluminum disc is limited to maximum half a revolution. Means gripping, there are produced two holes are cut in the aluminum disc. In the opposite, in the two sides, there will be two holes. Due to this, the rotation of aluminum disc is limited, and it will be limited to maximum half a revolution. Means due to this, the speed, the speed or the rotation of aluminum disc should be decreases. The disc stops rotating when one of the holes comes under any one pole of the shunt magnet, where the disc will be stopped. Due to these holes, the disc will be stops rotating when one of the holes is comes under any one of the pole. Cuts under any one of the pole. Means when the disc is rotated, and at that time one hole is uh, comes under the central limb, under the pole, any one pole of the shunt magnet. At that time the disc should be uh, uh, this the rotation of this will be stopped. The creeping of energy meter can be stopped by disconnecting iron wire or iron piece on the aluminum disc. This creeping error should be also minimized by connecting iron wire or iron piece on the aluminum disc. The brake magnet is a permanent magnet, hence it will attract iron piece, making the disc stationary. When the iron piece is connected on the aluminum disc, due to this, the braking permanent magnet attract the iron piece, and due to this, the disc will be stop rotating. Next one is fifth error. Now up to that, we are discussing the four errors. First one is phase angle error, friction error, speed error, and creeping error. Now next is temperature error. As the temperature causes an increase in temperature, suppose the temperature is increases, due to this temperature, the resistance of metallic parts should be increased according to the resistance temperature coefficient. This reduces in a small decrease in pressure coil flux. Due to this, a small decrease in pressure coil flux as resistance of the coil increases. Means as the resistance increases, the current should be decreases, and due to this current, the flux produced by the coil is decreases. This affects the pressure angle between the voltage across the pressure coil and pressure coil current. And due to this, the the angle between pressure coil current and pressure coil voltage should be changes. Second, decrease in torque produced by all shading band. This is caused due to the increase in resistance of the eddy current path in the aluminum disc. Due to this temperature, means as the temperature increases, first one, the angle between voltage and current of the pressure coil should be changes, and second, decrease the torque which is produced by the shading band due to the resistance increase. These errors introduced by these The errors introduced by these effects are known as temperature errors. Are known as temperature errors. These errors are small since the various effects produced produce work to neutralize each other. For example, temperature increases, resistance of pressure coil increases, hence the current decreases and flux also decreases. Hence the driving torque should be decreases. As TD decreases, the speed of the disc decreases. As TB is directly proportional to speed, hence TB should be decreases. Means as the temperature increases, the all the driving torque and braking torque should be decreased. Next one is frequency error. Energy meters are designed to operate accurately for a particular frequency, generally 50 Hz. If the supply frequency changes, the resistance of the coil changes. Small error will be introduced in the meter. Means as the frequency changes, then the reactance of the coil should be changes, and according to that, the meter should be showing the error. Next one is last overload error. This error is introduced in the meter when current coil of the meter carries current greater than the rated value of full load current. Means as when the overload condition is occurred, then at that time the current flowing to the current coil is increases, which is greater than the rated current, This causes saturation of the series magnet. Due to this, the more number of fluxes should be produced, and due to that, the coil will be saturated. Ammeter tends to be slow at high load current. Meter can be compensated for this error by providing the plug divider to the series magnet. Means as the load current increases, then the meter should be rotate slowly, and this error will be compensated by using plug divider of the series magnet. Plug divider to the series magnet. It is made up of such a material that it begins to saturate at the suitable value of overload current. Thus, it diverts a smaller portion of the flux at higher load and tends to increase the driving torque proportional to the load current. Means, as the plug divider is used in a series magnet, and due to that, the smaller portion of the plug at higher load, this will be used to increase the driving torque. This will be used for increasing the driving torque proportional to the load current. And according to that, the meter shows the reading according to the load current. This is your errors which is present in a single phase energy induction type energy meter. That is, first one is phase angle error, second is friction error, third one is speed error, fourth one is tripping error, fifth is temperature error, sixth one is frequency error, and seventh is your overload error. These are the errors which is present in a single phase induction type energy meter, and how to overcome this error. Okay, so thank you. In next lecture, we have studied that. In next lecture, we will study the three-phase energy meter and the numericals on the single-phase energy meter. Okay, thank you.